I know I get no views on my YouTube channel, but I do it anyway because I want to make sure that the baseball players can continue to enjoy class, even if they're not here. Okay, getting back to this. So that's that. And so we have some assumptions we make. Let's just skip over those for a sec. What does this say? Oh, a fair share. Okay, so this is important as well. What does it mean for someone to have a fair share? Well, if we're talking about the 4 people up here, a fair share is 1/4. 4 people, 1/4 would be a fair share. Now, some of you might say, well, you have however many dice here. I'm just going to guess that there are 48 dice. So a fair share would be 12 dice. Maybe, maybe not. You have to remember that each person has their own value system. And so if whoever it was, Logan with his little dice, if Logan likes the little dice, then maybe these 4 little dice are worth more than all of the other dice. And so this would actually be this would be worth more than all of this stuff combined. So I'm not sure how we're going to make a fair share for Logan. But Logan might say, I would be happy with the 2 black dice, 2 little black dice, or the 2 little red dice, or all of those, or all of those. So maybe that would be fair shares to Logan, where you have sort of this weird division. Whereas a fair share to Alex might look at this and say, this is ridiculous. That's not a fair share, but this is more than a fair share. So maybe Alex would be like, here, I'll just take all of this stuff. Here I am. I'm all done. So anyway, a fair share is just 1 over n if there's n people playing this whatever game it is. So here's how we're going to do this, is we're going to, because this is a math class, you'll notice all these charts here. Those charts just represent people's value systems for some sort of division of the goods. And so let's see, let me go over here to where we're going to start this business. There we go, loan divider. There it is, loan divider method. So here's how we're going to do this. Loan divider method for 3 people, and then we'll do it for 4 people. So the first example is up top. You'll see chooser 1, chooser 2, and divider. So first of all, let me just go through the description of this in words, and then we'll see how that applies to the numbers. But we will eventually do this top left problem up here, that grid. In fact, hopefully we'll do all of them, but we'll do as many as we can before we go here. So first of all, one of the 3 people we're going to call the divider. The other 2 people are going to be the choosers. So I don't know if you remember this before break, but I mentioned this idea of one of you divides, the other one chooses, if you're dividing between 2 people. So if we were dividing between 2 people, and we had some stuff, we might say, okay, you divide it into 2 piles, and then you pick whichever pile you want, and then the other person gets the remaining pile. And if you do that, then the person dividing is going to do their best to make the piles equal. And then the person choosing can say, I don't think they're exactly equal. I think that one's bigger. And they'll be happy because they get the bigger pile. And then the person who did the dividing will be happy because they did their best to make it half and half. But in the case of 3 people, it's not quite so easy. And so what we're going to do is we're going to pick one person to be a divider. We can do this at random, roll a die, flip a coin, whatever. And then the other 2 people are going to be choosers. So the first step is the divider divides the cake as best they can, or the stuff. I know I have it in terms of a cake here, but it's just whatever it is. Divide the stuff into 3 equal pieces. So actually it's pretty obvious because it's labeled as such. On this paper, you'll see the divider has divided the stuff into 3 pieces, and you see piece 1, piece 2, and piece 3. The divider thinks that they are all equal. The divider's job is to do the best they can, divide things as equally as possible. the next thing that's going to happen is the choosers are going to choose which of the pieces they think are acceptable. So to explain this, I'm going to need to go over here to this chart so that we can sort of follow along. So the divider, you don't have to highlight this, I'm just going to do it. The divider divides things as best they can, 33 1/3%. So each piece, you can think of it as a cake or some stuff that you're dividing into 3 piles, whatever. What they've done is they've divided it as best they can. Now the choosers, what they're going to do is they're going to make bids. Now, normally you won't have these percentages. I should say, if you were dividing a piece of cake among 3 kids, the kids would not have the percentages necessarily written down, but they could still look at the pieces of cake. So here's the situation. We have this cake. Whoops. Hold on a minute. Let me get rid of that giant C. C is for cookie. Okay, here it is. There's the cake. And it has been divided by the divider into 3 pieces. One, 2, and 3. So the divider thinks that those 3 pieces are all the same, but the 2 choosers are a little bit choosy about this thing, aren't they? Notice that they both think that piece 1 is better than pieces 2 or 3. And so for whatever reason, and if these are children, then probably there's going to be, like, if this is a decorated cake, there's probably going to be extra icing here. You remember what it was like as a kid? You always wanted the icing? Okay, maybe that was just me. But anyway, maybe there's like a special design here, whereas these are more plain. Whatever the issue is, chooser number 1 says, hey, piece number 1, that's actually 40% by my value system. And piece number 2 is 30%, piece number 3 is 30%. So in chooser 1's universe, piece number 1 is the only acceptable piece. And the reason is that we want to make sure everyone feels like they have at least 1/3. And if chooser 1 gets either of these, chooser 1 is going to be sad because chooser 1 will have less than 1/3 in their mind. What about chooser 2? Well, chooser 2 also thinks that piece 1 is the only acceptable piece. Pieces 2 and 3, too small. The only one that they'll be happy with is piece 1. And so here's step 2. So step 1 is the division. Step 1. Step 2. Chooser 1 says piece 1 is the only one that is acceptable. Chooser 2 also says piece 1 is the only acceptable piece. Okay, let me go back to the explanation. We'll come back to this picture in a minute. Okay, so that's the bidding. Each person just lists what is acceptable. And acceptable is anything that is at least 1/n. So if there are 3 people, it's 1/3. If it's 4 people, 1/4. I don't think I have any examples with more than 4. Okay, the next step is the distribution. We decide who gets what piece. So what we need to do is we need to separate the pieces into 2 groups. One group is the chosen pieces, and one is the unwanted pieces. We're going to give person 1 one of the unwanted pieces. So that's what's going to happen. So person 1 will get an unwanted piece. Well, where is this? Just a minute. Where's my unwanted? Where's the unwantedness? Step 2, we've already talked about that. Okay, the distribution. Let me just go. We'll just demonstrate this here. Okay, so in terms of step 3, step 3 is divide the stuff. So you have step 3. We have piece 1 is chosen. So notice that piece 1 was chosen by both of them. and unwanted are piece 2 and piece 3. Now your job, which sometimes it'll be obvious and sometimes it won't be, is to try to divide things up so that everyone will be happy. In this case, it's impossible. See how you have 2 unwanted pieces? If you have more than one unwanted piece, then there's no way to make everyone happy. I'm just telling you. So, well, there is a way, and I'll explain it. But the next step is to give person 1, the divider gets one of the unwanted pieces. It doesn't matter which one. So let's just pick one. The divider gets piece 2. Let's just do that. So the divider is going to get piece 2. Now, if it is possible to make everyone else happy, then we're going to do it. If not, we're just going to be stuck with having to redo this whole procedure. So here's how this would work. Piece 2 is going to be gone. What that means is that all you're left with is pieces 1 and 3. I don't know why I just outlined that, so I'm just going to go ahead and erase this. So piece 2 is gone. Let's get rid of this line here. And then we redo the whole thing by taking pieces 1 and 3 and putting them together. So what this is going to do for us is the divider takes what they think is 1/3 and what everyone else thinks is less than 1/3. That means that what's left, everyone thinks this is more than 2/3. So if we divide this in half, everyone will feel like they have more than half of 2/3, which is more than 1/3. I know, the math is a little bit dizzying, but it's not bad. So then we go through the division process again. Maybe chooser 1 now does the division. And then chooser 2 gets to pick which of those pieces do they want. So the new division will likely not be the same as the old division. And now person 2 or chooser 2 gets to choose. Let me show you an example. This one's not a good example to start with because I don't know why I put that first on maybe I was just, let me see if this one's better. This one is much better. Let's do this one. Should have had this one first. So here's our job. We have step 1, the divider has divided. So here's the divider here. And now what I want to know is what does chooser 1, what do they think is acceptable? So that's the first thing. So remember, we have 3 people, so any number bigger than 33 1/3% should be acceptable. So let me find a volunteer here. Give me a sec. We have Ryan. What? There's no Ryan. Okay. This must be, I don't know why this. We have Addison. Addison's here. Addison, chooser 1. What would chooser 1 say is acceptable to him or her? Not piece 2? Yeah, I guess you're right. Just piece 1. Because notice that piece 2 is less than 33 1/3%, and piece 3 is also less than 33 1/3%. Okay, chooser 2. Let's go with Lucas. Lucas, what does chooser 2 think is acceptable?
Piece 1, 2.
Yeah, piece 1 and piece 2. So you're just picking the ones that are bigger than 33 1/3%. Now we go ahead and see if we can divide this up. So let's see, we have the chosen. The chosen pieces are piece 1 and piece 2, and the unwanted is piece 3. So here's how I'm going to do this. I will take the divider, and the divider gets piece 3. So we'll just get rid of the divider, get rid of piece 3. Now it's a little tricky, and unfortunately this kind of caters to picky people. But what we'll do is we'll try to satisfy everyone in the sense that everyone gets at least 1/3. So notice that chooser 1 is more picky than chooser 2, so let's deal with chooser 1 first. Chooser 1 is going to get piece 1, because that's the only thing that's acceptable to chooser 1. And that leaves piece 2 for chooser 2. And now if you box that up, the important thing when you get done with a fair division like this is everyone needs to feel like they have at least 1/3. So let's look at the divider. The divider feels like they have exactly 1/3. Person 1, chooser 1 has what they think is 40%, which is bigger than 1/3. And then chooser 2 has what they think is 35%, which is also bigger than 1/3. So everyone should be happy. I realize that it's impossible to make everyone happy usually because we aren't dealing with rational people, but technically everyone has at least 1/3 in their minds. And so that's the way that we're going to do this. Okay, let's try one that has a little bit more complication to it. We have these 4 people, and let's start with figuring out who the divider was. So one of these people divided this stuff up, whatever it is. It might be land, it might be a cake, it might be whatever stuff that we're trying to distribute. So see if you can guess which one of these people is the divider. Brad, which one of these people do you think is the divider? Yeah, why do you think that? Yeah, so he thinks that all the pieces are worth the same. So notice that means that he must be the divider. He or she. I don't know if Dorian, usually that's a male name, isn't it? Okay, so Dorian thinks that it's all the same. So Dorian is the divider. Now we have to go through and get the bids. So A, B, and C, Abby, Brian, and Chris, what are their bids? And remember, we're dealing with 4 now, and so anything bigger than 1/4 will be acceptable. So let's see how you're doing with this. Where are we? Lilla, what do you think of person A, Abby? What does she think is acceptable? Yeah, piece 2 and 4, because both of those are bigger than 1/4. So piece in that person's mind, in that person's value system. I mean, one good example, well, I don't know if it's a good example, but one example that I can think of where a value system really matters is if you had a cake and half the cake was chocolate and half the cake was vanilla, and someone was allergic to chocolate. Like they would have to go to the hospital. I know it's kind of far-fetched, but let's say that was the case. Then they would value the chocolate side as being worthless, completely worthless to them. The vanilla side would be worth the whole cake. And so someone else might be like more 50-50 about it. And so depending on how you cut the cake, they might feel that they got a worthless piece, or maybe they got one piece that's worth almost the whole cake. But anyway, getting back to this, let's do B, Brian. Who are we up to now? We're at Lily. Lily, what about Brian? What's Brian think is acceptable? Piece 1, piece 2. Very nice. And then one more, Sydney. What about Chris? Just piece 2? Chris is picky. Okay, so now let's see if we can come up with a division. I think we can with this one. The first thing is let's determine how many unwanted pieces there are. I think that piece 3 is the only unwanted piece. Is that right? Oh, yeah? Yeah, what do you say, Laura? Oh, I missed that. And so did whoever told me it was just, or maybe I just misheard. Yes, you are right. 25% is acceptable, isn't it? So very nice. Thank you for that. Piece 4. That'll make our lives perhaps a little bit easier. Well, actually, yeah. We'll still get the same answer. But nice catch there. Okay, so what is unacceptable to everybody? So, Allie, you're here. Okay, Allie, what's unacceptable to everybody? Yeah, piece 3. Piece 3, no one wants piece 3. And so that's the only piece that is unacceptable. So whenever there's either no unacceptable pieces or one, you can find a fair division usually. It's when there's more than one unacceptable pieces, that's when you run into trouble. So D is going to get piece 3. So now that gets rid of piece 3. Now let's deal with the other people. And there's no one way to do this. Well, in this case, there is one way. But what I'd suggest is start with the pickiest person or the pickiest people and see if you can give them what they want. And then work your way backwards from that. So for example, here, C is super picky. So C is going to get piece 2. And then A is, now that piece 2 is gone, A is only has piece 4 on their list. And then that leaves B getting piece 1. It is possible that you might end up with 2 different ways of dividing up some junk, but for this is pretty much it. You also might run into trouble if you have 2 people who are just as picky as one another. For example, let's just suppose, so this isn't the case, but let's just suppose that person A and person B, or C, so let's say that, piece 2. Let's say that person A and person C felt the same way. Then what you would do is you would do the same thing that you would do in the case of 3 people and the chooser and the 2 dividers can't decide. You would just, I don't know if this is piece 2 and piece 4, is that right? Anyway, you would just pick one of the 2 unacceptable pieces and then lump the other 2 together to, would that work? That might not work. Wait. No, that should work. Yeah, that should work. What I mean, yeah, sorry, it's just the math. We want to make sure, like if you give person B one of those 2, what you're doing is, in essence, giving person B a piece that the other 2 people feel is smaller than 1/4. So you've gotten rid of 1/4 to D, you've gotten rid of 1/4 to B. You're left with 2 pieces that together are more than 2/4 together. And then you do the divider chooser thing. Okay, let's move on. Wait, didn't we just do this? Oh no, this is a new one. It's at the bottom. Wait, there's 3 that look all the same. Are they? No, wait, the first 2 are the same. This one's the same as this. Yeah, those are the same. Okay, so I messed up and I have 2 that are exactly the same. So let's go to the very bottom. What? Wait a minute. Where did, why does my bottom one not show up? Is that the bottom one? Yeah. Oh, it is different. Wow, it's such a subtle difference. Okay. So the only difference here is that Brian has changed his tune. So here, Brian thinks that piece 1 is 30%, and then here, Brian thinks that piece 1 is 20%. Okay, I guess I have 2 of the same on my paper. You can skip one of them. Go to the very bottom on the left, and you'll find the one that we're working on. So let's try this one. Dorian is the divider again. So divider. So those are all the same, so we'll just do that. I'm just going to circle or maybe highlight the pieces that people feel are acceptable. So Dorian feels that all of these are acceptable. Now let's find the other things. Oh, your friend isn't there. Okay, Ethan McNaughton. Ethan McNaughton. What do you think about Abby? What does she think is acceptable?
Piece 2 and 4.
Okay, so piece 2 and 4. I'm going to highlight these, maybe in green for go. They're both acceptable. Now, Dylan, what about Brian? What does he think is acceptable? Same 2. Okay, 2 and 4. All right, almost done. And then Nick Klein, what about the Chris? Just piece 2. So here you run into the same problem as before, where there's more unacceptable pieces. So let me just do this. These are unwanted. So there's too many unwanted pieces. And so what we're going to do is we're going to give Dorian one of those unwanted pieces. It really doesn't matter which. In either case, since it's an unwanted piece, all the other people feel like it's less than 1/4. So give Dorian, so Dorian gets piece 1, and then Abby, Brian, and Chris, they're going to put together piece 2, piece 3, and piece 4 into a new sort of whole. So it's as if you've taken the cake that was cut. Maybe it wasn't really cut. Maybe they just put a line on the top of the cake to say, here's where we're going to cut it. Whatever. And then take the stuff that Dorian didn't take and divide it up again. And so then in the second, so after you've put those 3 pieces together, you might go through the process again, pick a new divider, and what you would get might be this table at the top of the second column. So notice now it's just Abby, Brian, and Chris. And so they've put the 3 pieces together, the piece 2, 3, and 4, and then they did the division again. Now, once again, the important thing here is that you've gotten rid of less than 25%. So what you've got here is more than 3/4 of the original. Everybody thinks that this is more than 3/4 of the original, what we're going to be dividing up here. Notice that you can actually say how much they think it is. Chris thinks that the piece that Dorian got was worth 20%, and so that means that the rest is 80%. So Chris thinks that there's 80% left. Brian thinks there's 80% left, and Abby thinks that it's even better that there's 85% of the cake still left to be divided up. So we get rid of Dorian, send him on his happy way with piece 1, put the other 3 pieces together, smooth out the icing and have them cut, or have Brian, I should have asked, too late now. So the divider here is Brian, divider. And the way you can tell that he's the divider is that he thinks that these are all the same. So let's do the bids again. So with this new cutting, Abby and Chris. Let's find out. Well, I guess I could just highlight up above. Why don't I do it that way? Logan, what does Abby think is acceptable?
Piece 1.
Just piece 1? Well, that's going to be a problem. Okay, then Alex Helber, sorry. What about Chris?
Looks like also piece 1.
Just piece 1. So in the case of this second division, you have these 2 unwanted. So they're unwanted by everyone except for the divider. So just give person, I guess the divider is going to get one of those. You can pick it at random if you'd like. I know that there's probably some opinions as to how you should do it, but let's just do it this way. Brian is going to get piece 2. And that means that we're going to take pieces 1 and 3 and just do the cut and choose method with them. So Abby and Chris are going to take pieces 2 and 3. And so notice what happens though. Brian gets piece 2. Brian thinks he's got 1/3 of 3/4 of the original. 1/3 times 3/4 is 1/4. So Brian is going to be happy. Abby and Chris are going to take piece 2 and piece 3 and put them together. And then they're going to have to do the cut and choose method with those. But notice that they think that this is more than 2/3 of more than 3/4 of the original. So the stuff that's up here was more than 3/4 of the original, and now what we're going to get is more than 2/3 of that. Multiply 2/3 times 3/4, And what you're going to have is 1/2. 2/3 times 3/4. Here, I'll write it down. We got to do at least a little bit of arithmetic here. Cancel the 3's, you get 2/4, which is 1/2. So they're dividing up. Abby and Chris are dividing up what they think is more than half of the original, meaning that each of them should potentially get more than 1/4 of the original. So they should be happy. So that makes everyone happy. That's the goal, is to make everyone happy here. Okay, let's see. Do we need to at least talk? Yeah, we have a few minutes left. We're in good shape, and I want to make sure I peek at the homework to make sure that it's all makes sense. So here is a situation where you have pieces that have values associated with them instead of percentages. And this sometimes happens. In fact, it will happen quite a bit on Friday when we talk about inheritance. So we're kind of gearing up to inheritance, which is where this stuff is actually used in the real world. But for this one, we've got these 4 people, and they've got their bids as to how much they think each of the pieces of something is worth. I'm sure there's a story behind this. I just copied it from a book that I had. So I've just got the numbers here. So first thing, who did the dividing? So that's the first thing to determine. So I think we're up to Abby Krumbacher. Who do you think divided this stuff up? Yeah, so Caesar thinks that everything's worth the same. And so because of that, Caesar thinks that, or Caesar must have been the person to divide this stuff. So there's that. Now for the hard part. I believe that this was done in such a way that each of these rows add up to 320. So the total for each of these is 320. 320, maybe this is a piece of land that is worth $320,000. But whatever the situation is, everyone here thinks that the total is worth $320, or maybe these are thousands of dollars. That would make more sense if we had some land we were dividing up. So Caesar has divided up, let's pretend it's land, in such a way that each of the plots of land Caesar thinks is worth $80,000. Now let's deal with the bids. So remember, anyone is going to bid or say that is like, they're going to say what's acceptable to them, and what's acceptable is going to be stuff that's worth 80,000 or more, because 80,000 is 1/4 of the total. So take a minute, highlight, circle, put a check next to, do whatever you can to indicate the bids, the things that each of these people think are acceptable. All right, Jack, what do you think about Sonia? What does she think is acceptable? Very good. So anything that is 80 or more is going to be acceptable, because that's 1/4 or more. All right, Adriana, what about who is going to do that? Isaiah, what do you think of Adriana? Just piece 3? And 4. Very good, because either of those is going to make Adriana happy, because either one of those is valued at more than 80. Finally, Raquel. So what are we up to? Adele, what do you think of Raquel? Same thing, piece 3 and 4. Very good. Okay, so now let's deal with the wanted and unwanted. So Alex Corson, which of these pieces are unwanted? Yeah, that's the only one. That's the only unwanted. And so because of that, we have the potential for making this work out. So let's see if it'll work out. I'll circle who gets what. So Caesar is going to get piece 2 because no one else thinks that's an acceptable piece. So Caesar's gone. Caesar is happy because Caesar thinks they're all worth the same. All right, Caden, what piece should we give to Sonia, do you think? Yeah, so here, this might take a little bit of experimentation, just to warn you. So I guess I just picked you out of the bunch here and threw you into this. But yeah, so piece one, you might have to do a little bit of experimentation, but let's give Sonia piece one, which means we have to give Adriana one of these other two pieces and Raquel one of the other two. Usually you'll be able to see sort of how things are going to shake out based on who thinks what is acceptable. Now at this stage, we can either give Adriana piece 4 and Raquel piece 3, but if we see the bids, if we know what the bids are, why not give Adriana piece 3 and Raquel piece 4? Technically, they should be happy if it goes the other way, because if they got these, they still have more than they would have expected. They have more than 80. But in this case, if we give those two to them, they'll be even more happy, because then they'll be like, well, I got the very best piece that I thought was there. All right, there's one more there, this one with the Maggie, Meredith, Holly, and Zoe. I think you probably get the picture here. I want to take a peek at the homework, so if you give me a minute, I'm going to pull it up and put it on the screen. Math systems, give me a sec. Okay. So isn't this exciting? We are down, let's see, give me a sec to turn this off. We're down here after spring break. There's this lone divider homework. So just a couple of things. This thing where it says Cindy's declaration, that's just Cindy's bid. So which ones does Cindy feel is the most acceptable? So that's that. That shouldn't be hard. A note about this one, you'll see Cindy Jamal, and you'll say, where's the third person? Well, the third person is Monique, and Monique thinks that they're all the same. So they've left off Monique just because they're all 33% for Monique. So when you get to that one, don't let it throw you. So that one's not bad. Let's see, that one's not bad as well. Give me a sec. There's one of these that's a little bit problematic. Oh, that's it? I thought there was something else. Huh. Oh, dishonestly. That's it. Yeah, this one. So, so for this one, you have this greedy person who thinks that they can scam the system a little bit. Where does it say? I thought. Oh, I see. Okay, so here's what greedy does. So the greedy person. So what they're saying here is do this the same way that you would do the other ones. So for example, Danny here is the divider. Brianna only thinks S1 is good. Carlos thinks S1 and S2 are good. Greedy thinks S1 and S3 are good, but he thinks S1 is bigger than S3. And also thinks that S2 is good. And so Greedy decides to only bid for this, even though, so he's dishonest and says, hey, I just think that S1 is the best. Then they want you to explore, what would happen if they did that. Do your best with that. We'll always probably have to do it on Wednesday, but just to see how that shakes out. But it turns out that Greedy gets less because he was greedy, at least in this situation. So, okay, I think that's it. If you want to stick around and argue with me about your exams, please feel free to do so. I'm going to turn off the recording right now.